Hello, this is Mr. Wyrick, and I'm here to talk to you today about lesson 7.2, the second lesson from chapter 7, and this one is about similar polygons. This is why we did all the stuff on ratio and proportion yesterday, and really the bulk of that information is the kind of work that you are going to be doing today. There's just a couple more things that you need to add to your notes, take a look at to get the work done on 7.2, the lesson. So a similar polygon is the same shape but not necessarily the same size, or not always the same size. If you remember, this is our symbol for congruent, and this is our symbol for similar. The similarity is included in congruency. So if two shapes are exactly the same, then yes, they are similar. It's just more descriptive to say that they are congruent. But if we have a tiny little 1-inch square, and I pick squares because they're kind of the easiest thing to talk about, because all squares are, by their very definition, similar, because all of them have all four sides the same. So you just have to find a ratio that moves from one to the other, and you've got similarity. The angles in these similar polygons are always congruent. So if we have a 30, 60, 90 triangle that's very small, and a 30, 60, 90 triangle that's very large, they are similar. We can use the size of one to find the size of the other. This is if you've ever done something where they've asked you to calculate how big the shadow of something would be based on how tall it is, based on your own height and your own shadow, using right triangles, comparing right triangles, things like that. This is something that you have maybe done before, okay? You just maybe didn't call it similarity. Okay, so in the similarity, they have all the same angles. For squares, it's 90 degrees all the way around. You know, we talked about the 30, 60, 90 triangles, 45, 45, 90 triangles, any other kind of shape to where all of those angles are going to be the same. You've got similarity. That's why we don't have angle, angle, angle congruency in triangles, is because angle, angle, angle only proves similarity. When we have similarity, we have what is called a scale factor, and a scale factor is the number that you need to multiply by in order to change one of them to the other. So if I have a very small pentagon and I'm changing it to a larger pentagon, I'm going to multiply by some number and it's going to make the other one happen. Now, with scale factor, you have to be very careful because the direction that you're moving matters. And on similarity, just as with congruence, if they say that the two shapes are similar, AB will be similar to EF. AC, now I've got this drawn wrong, go figure. CD would be congruent to GH. How they have them listed is always the way that they work, okay? So same thing with scale factor. If I say I'm moving from this one that is 1 inch square and I'm going to this one that's 12 inches square, my scale factor was 12 because I have to multiply 1 by 12 to get 12. But if I'm going from this larger one down to this smaller one, the scale factor would be the reciprocal. It would be 1/12. So I would have to multiply 12 by 1/12 in order to get 1. It's always what you are going to multiply by, not what you are going to divide by. So in some cases it needs to be a fraction, a decimal, something like that. It's a little easier with fractions because you can think in terms of reciprocals based on which direction you're going. If any part of this wasn't clear, if you had trouble understanding it, make sure to come in, ask some questions, because more and more of this chapter is going to be about similarity between figures and calculating different things based on that. Again, if you have questions, come in the morning, talk to me during class, and we'll see you then.